Hi guys, so welcome to the new session. In today's session, we are going to do the graphs on logarithmic function. Okay, so let's start with the definition of log. So the definition of log says that if if you are given with a function y equals f of x, and which is equal to log of x to the base a. Okay, so this function is bounded by certain set of rules. Okay, what are those rules? First thing is that this x it must be the positive real number. Okay, and second thing is that this a must be greater than 0 and it should not be equal to 1. Okay, or in other words, I can say that this a will be, it belongs to 0 to 1, open brackets, union of 1 to infinity. Okay, it means it can take any value between 0 and 1, but not 0 and 1. And the union, it can take any value from 1 to infinity, but not 1 and infinity. Okay, because a should not be equal to 1 as per the definition, and infinity is not a number, it's just an idea. Okay, so that's what it says. All right, so now we will break uh, sketching the graph into two different things. First, we will draw the graph when our base a belongs to any number between 0 and 1, and in other one we are going to sketch the graph when base takes any value between 1 and infinity. Okay, so let's start with let's start with let's start with a. This side we are going to plot for a greater than 1, and here this side we are going to do it for when a is between 0 and 1. Okay, so uh, all right. Okay, I hope this is visible to you. Okay, so here we are going to take base greater than 1. So let's say that here our base is 2. Okay, so if our base is 2, then y is going to be log of x to the base 2. Now see here, because it's difficult to find the values for this function, so what I can do here is I can change this function into the exponential function, right? So what would happen? 2 of y is going to be x. Okay, now what I will do here, I will draw the ordinate table. Okay, for that I need xy plane first, right? So this is going to be my xy plane, and here 1, 2, 3, 4, 5, 6, 7, 8, 9. On this side, -1, -2, -3, -4, -5, -6, -7, -8. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and here -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, how are we going to sketch the graph? We are going to get different values of x and y, and then we will draw, we will find those values on the graph, and then we're gonna trace the curve. Okay, so here is my ordinate table, x, here y. Okay, here I can take different values. Okay, so here what I can do is first, if what happen if x is going to be 0, if now see here, uh, 2 of y is equal to x. It means if my y is going to be 0, x is going to be 1. So y0 x1 means this point, right? Then if if x is going to be 2, then it means y is going to be 1. So x2 y 1. Then if x is going to be 4, then y is going to be 2, right? So x4 y is going to be 2, this one. Then if my x is going to be 8, then y is going to be 3. x8 y is going to be 3, this one. Okay, now we can take some negative values here. So if we take y, if we take sorry, not y, if we take x, uh, if we take x minus 2, right? If we take x minus 2, then y, it's going to be, if we take x minus 2, if we take, now if we take y to be minus 1, right? Minus 1, then your x is going to be, your x is going to be 1 by 2, right? And if we take y to be minus 2, then it's going to be 1 by 4, right? And if your y is minus 3, then it's going to be 1 by 8. And if you take all right, I think these values are fine to uh, trace the graph. Okay, now if you want, you can take more. If y it's going to be minus 4, what would happen? If y it's going to be minus 4, then x is going to be 1 by 2 raised to power 4, which is 1 by 16. Okay, so let's see. So here y minus 1, x 1 by 2. X 1 by 2 means 0.5. So this point, and y minus 1, and x this one, right? Then y minus 2 and x 1 by 4, y minus 2, and this is 1 by 4, so it's going to be here. Okay, then minus 3 1 by 8, minus 3 1 by 8, it's going to be close. Okay, then minus 4 1 by 16, minus 4 1 by 16, it's going to be here. Okay, so if you trace all the points, then in the end you are going to get a graph like this. Graph like this. In the end, you are going to get graph like this. Okay, so this is the graph that you are going to get in the end. So this is the graph of y equals log x to the base 2. Okay, so here you can see one thing, that as you increase, now see here what's happening here, as you increase x, y is increasing, right? See here this point is 1 0. Okay, if you take any, for example, here x has a negative value, here sorry, here x has negative value, and the y of sorry, x not, x is having any value between 0 and 1, but y has a negative value. But as it crosses 0, as you increase the value of x, the y is increasing too. What does it mean? It means it is increasing, it is increasing function. Okay, so the when you sketch the graph of logarithmic function where base is greater than 1, then you are going to get the graph of increasing function. Why? Because you can locate any 2 points. For example, you can locate this point, and you can locate this point. Here you can find that y value of y is increasing. Okay, so that's why it is an increasing function. Okay, it's same like when we sketch the graph of this exponential function, a raised to x or 2 raised to x. Then what type of curve did we get? If you remember, it was like this. It was like this curve, right? And here it passes through 0 1, right? Because if you look at every point, if you compare 2 points, the value of y is increasing. So that's why this graph of 2 raised to power x exponential function is also the graph of increasing function. Okay, same here. Now here there is one thing that you have to observe. Later on in the next session, we may compare the graphs of exponential and logarithmic function. So now see here, this point is very important, 1 uh, 1 0. Why? Because no matter what no matter what your base is, every time you sketch the graph of any logarithmic function, this graph will cross the x-axis at this point, 1 0, same as what we did in the exponential functions. If you remember, the graph of any exponential function, it will pass y-axis at 0 1, right? So same here, the graph of any logarithmic function will just pass the x-axis at this point, 1 0. Okay, so I hope you get this point. Now what happens is, if you draw the graph, if now we can increase the value of a. Now we can make for y equal log of x to the base 4. So it will be 4y equal x. Okay, 4y equals x. So what I will do here, here I will get some values of y. Okay, some values of y. All right, so here 4y equals x. Okay, so if we take y, now see here, if we take y equals 0, x is 1. If we take y 1 1, then x is going to be 4. X is going to be 4. If we take y 2, x is going to be 16 16. If we take now if we take some negative values, y minus 1 minus 1, then it's going to be 1 by 4. Okay, if we are going to take y minus 2, it's going to be 1 by 16. Okay, so I think we have enough values. So see here, 0 0 1, again the same point, and then 4 1, x4 1, this one, and then we have x 16 2, oh 16, it's I mean, my scale is not that long. Okay, so then next here minus 1, when y minus 1, so here I have 1 by 4, 0.25, so it's going to be 0.25 here, minus 1 here, here. Okay, so this is going to be, my graph is going to be something like, okay, so this black represents the graph of log y equals log x to the base 4, and this blue y equals log x to the base 2. Okay, now here you can see one thing, that uh, as you increase the base, okay, if you take the log of any positive real number, for example log x, okay, here base 2, here base 4, here base 6, so which is going to give you the greater value? Okay, so which is going to give you the greater value? So this is going to be greater, and this is going to be greater than this. Okay, so you can observe this thing here. So if you are going to sketch a graph for log base 6, then it will be something like this. Understand? Okay, so please keep this thing in your mind, and just put one thing in your mind, that all the logarithmic functions graph will pass x-axis through 1, 0. Okay, very important. And when your base is greater than 1, a greater than 1 means your graph is going to be increasing. Graph is increasing. Okay, it is increasing function. Okay, now we'll go to the other side, and we'll see how things are here. Okay, here what we will do here is that we will take y equals log x, and base we can write here 1 by 2. Okay, so this thing can be represented as y equals x, right? Or I can say 2 raised to exponent minus y equals x. Okay, so here I can draw the graph. So here 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 1, minus 2, 3, 4, 5, 6, 7, 8, minus 9, minus 10. Okay. Okay, one thing that I forgot to mention here is that this line is never going to touch the y-axis. Okay, so we will come to that part later about the domain and the range. Okay, very important. Okay, now here what we'll do is, do we have space on the right? Okay, you can see, yeah, we do. So here we can just make the table. Okay, so all right, so here let's take the values. If what happen if I take value y0, then x is going to be 1. Okay, if I take y minus 1, then x is going to be 1 by 2. if I take y minus 2, x is going to be 1 by 4. Okay, and if I take y minus 3, then x is going to be 1 by 8, right? Now we can take some positive values. If we take y, no, if we take, these are positive values, right? If we take, yes, these are positive values because it's minus y. Okay, if we take some negative values, y minus 1, then it's going to be 2. If we take y minus 2, then minus of minus plus 2, it's going to be 4. And if we take minus 3, it's going to be 8. So let's plot the graph. Y0, x1, y0, x1, y0 means this point. So I've told you all the logarithmic graphs will pass through this point, x-axis to this point, 1, 0. This is 1, 0. Okay, then y1 x1 by 2, y1 x1 by 2, y1 y1 x1 by 2. So where is, this is y1, and where is, this is y1 and x1 by 2. So this point, this is 1 by 2, 1 by 2, 1. Then y2 x1 by 4, y2 x1 by 4, this point, 1 by 2, sorry, 1 by 4, 1 by 4, and 2, this point. Now come to this side, greater than 1, right? So x2, sorry, here 3, 1 by 8 is going to be this. Okay, then x2 y minus 1, x2 y minus 1 is 1. Then x4 y minus 2, 4 minus 2, this 1. Then x8 y minus 3. Okay, so the graph is going to be like this. Okay, if you trace all the points, your graph is going to be like this. So this is the graph of y equals log of x to the base 1 by 2. Now see here, this graph is it's a decreasing function. Decreasing function. Why? Because if you take any 2 points and you compare the values of y, for example, any point here and any point in the next interval, if you compare, you will find that, for example, okay, for example, this is my 1 point and this is my next point. Okay, this is my x1 and this is my x2. Okay, now if you see here, so the value